The distributed file system is a server-based technology, so for the most part this isn't going to be too intensive on the exam. It's more important for you to understand how clients interact with the service. It's a role service which is installed by a server administrator. It supports replication between instances of DFS folders. It also supports replication of the namespace. And DFS consists of one or more namespaces, folders, and folder targets. A DFS namespace provides a virtual representation of your shared folder structure. So as you can see here, each server has a shared folder called data. If a user in Pearson wants to access all 3 data folders, they've got to remember 3 separate UNC names. For example, /Pearson lonserv 1/data. And likewise, one on the NYC server and one on the SID server. By deploying a DFS namespace, you can consolidate those separate shared folders into a single UNC name. For example, /pearson.com, which is the domain name, /data. This is far more convenient for your users. A DFS folder is the top-level UNC path to one or more DFS folder targets. A folder target is a link to a shared folder on a file server in your organization somewhere. To create folders and folder targets, use the following procedure. Create a folder in the DFS namespace, and then add one or more target folders. Because, in essence, the DFS namespace acts as a route that points to multiple servers and multiple shared folders, it's important that this is highly available. For that reason, you can configure DFS Namespace Replication on a server. For a domain-based DFS namespace, you can add multiple namespace servers, which enables you to provide namespace replication and helps to provide high availability of the namespace. DFS Replication enables you to synchronize copies of folder content between instances of folder targets throughout your organization. There are a number of situations in which this might be useful. When you're supporting branch offices, for example, you could collect data from branch offices and replicate that to a central point. You can distribute data from a central point out to your branch offices, or you can share data throughout the branches. You can see an example here. Using a domain-based DFS namespace in the top left with the name of /pearson.com/org-data, you can point that to one of 2 locations, either /serve1/data or /serve2/data, depending. So a client will connect, or a user will connect through their computer to pearson.com/org-data/folder name and be directed to one or other of the folder targets. DFS replication ensures that the 2 targets are maintained in a synchronized state. Storage spaces were introduced with Windows 8 and Windows Server 2012. They're used to enable you to combine multiple physical disks, and they provide storage redundancy by pooling those disks. Storage spaces can use either NTFS or the REFS file system. Storage spaces consist of the following components. The physical disks. You can use any size disk and any type. You require at least 1 physical disk for storage pool and more for mirroring. When you create your storage space, do not initialize or format the disks. Your storage pool, you'll need 1 or more physical disks to create a virtual disk. You can add all unformatted disks to a storage pool. A storage space is a logical disk which you created from 1 or more physical disks. It supports thin provisioning or just-in-time disk allocations, which can offer resilience to physical disk failure through the use of mirroring. Disk drives. By allocating a drive letter, your storage pool is accessible through the file system. There are a number of layout options when you create your storage space. Simple. A simple space has data written across all disks in a logically sequential way, which offers increased performance. Simple spaces provide no failover capabilities. 2-way or 3-way mirrors. Mirrored spaces maintain multiple copies of the data by way of data duplication to ensure that all data is redundant. 2-way mirrors maintain 2 data copies, and 3 data copies are maintained for 3-way mirrors. Parity is similar to RAID 5, which stores data along with parity information across multiple physical drives. There are a number of provisioning options. Thin provisioning enables you to allocate an intended storage that has greater capacity than you physically got in the computer at the time of creation. If you overspecify the amount of capacity compared to the data you currently have, the storage space engine disregards the extra storage capacity until the dataset's grown to the required storage, and at this point the extra storage is allocated. At any point, you increase the maximum size of an existing storage space and add drives as they're required at a later date. Thin provisioning is more economical and efficient because it allows you to deploy physical storage only when needed, therefore saving on operating costs. Fixed provisioning is similar to traditional fixed storage allocation methods, by which you specify that the spaces will not increase beyond the initial storage capacity allocated at the time of storage space creation. With fixed provisioning, you specify the hard limit for the size of the storage pool. To create a storage pool, click Start, type Storage Spaces, and then Open Storage Spaces. Select Create a New Pool and Storage Space. Accept the UAC prompt. Select the drives you want to configure as shown here, and click Create Pool. When the Create Pool operation completes, provide a name for the storage space and select the drive letter you want to use. Select the type of resilience you require. Select either NTFS or the REFS file system. Set the size maximum of the storage space, and then click Create Storage Space to create your storage pool in the storage space. You can use the following Windows PowerShell commandlets. New Storage Pool creates a new storage pool using a group of physical disks. Add Physical Disk adds a physical disk to a storage pool for the creation of one or more virtual disk objects. Get Storage Pool gets a specific storage pool or set of storage pool objects that are available. Set Storage Pool modifies the properties of the specified pool. Set Physical Disk sets the attributes on a specific physical disk. Get Virtual Disk returns a list of virtual disk objects. New Virtual Disk creates a new virtual disk in the specified storage pool. Repair Virtual Disk deletes an existing virtual disk and reclaims the space for use by another virtual disk in the same storage pool. Optimize Storage Pool rebalances a storage space configured as simple or mirrored, optimizing files based on disk space, disk size, and file size. Update Storage Pool upgrades the storage pool metadata to enable new features for more recent versions of Windows. Remove Physical Disk removes a physical disk from the specified storage pool, and Remove Storage Pool deletes the storage pool and its associated virtual disk objects. Let's take a look now at how to create a storage pool and how to create a storage space. Okay, let's open Disk Management. I've got 4 blank uninitialized disks. I'm going to stop Windows from initializing those, and we can see that they contain nothing at the moment. Manage Storage Spaces. Create a new pool and storage space. Confirm the user account prompt. We've got these 4 unformatted drives. I'm going to create a pool. So now I need to give it a name and a drive letter and choose a file system, and then select the resilience type. As you can see, it's defaulted to two-way mirror, but I can go for simple, three-way mirror, or parity. That's because I've got 4 drives available for use. I'm going to go for a two-way mirror. I'm also going to accept the defaults for everything else here. I can specify the maximum size. Each of these available space is 505 gigabytes. The pool capacity is 504, and I'm going to set the maximum size to the default, in this case of 251, and then click Create Storage Space. Okay, that's completed. It tells me that the storage space, drive E, two-way mirror, 251 gig using a 2 gig pool capacity. I can expand out and have a look at the physical disks. And I've got the options to add drives, rename a pool, or optimize drive usage here. And if I go back to disk management, we can now see that we have a disk 5. So you'll remember we actually have disks 1, 2, 3, and 4 that weren't initialized, but it's now been labeled disk 5 basic 250 gig. So the nature of this is hidden from the operating system. The storage space is viewed as a single simple volume on disk 5. In the demonstration, you saw how to create a storage pool and how to create a storage space.